Right. Before I start the new topic, any questions on what we have learned previously? Any questions? This is actually just to introduce some terms in factorial experiment. In factorial experiment, basically. We could consider, could you remember we talked about main effects and interaction effect. We talked about the main effects and interaction effect. In interaction effect also, it depends on the different factors. So the number of factors, the interaction effects vary. Two-way interactions, three-way interactions, and so on. Right? So talking about this effects. Talking about this main effects and the interaction, right? Talking about this main effects and the interaction, these effects can be further classified into two groups. It's called as random effect or fixed effect. So all of you know what is this main effect and interaction that we have already learned. So today in the morning, we are going to talk about what is this random effect and the fixed effect. So that name implies random. Everybody knows what is the meaning of random, right? Everybody knows the meaning of fixed. Fixed is fixed. It doesn't go around. Random means anything is possible. Any value is possible. Right, to talk about these two effects, random effects and the fixed effects, I will consider two factors. Let's say factor A. Right, nowadays we are talking about fertilizer. Have you heard about organic fertilizer? Yes. Harosha? Harosha? What is the, let's say this is organic fertilizer. Harosha, tell me what is the nitrogen content of average organic fertilizer? Content percentage? Anyone? Agronomy people, soil people, biology people. What is the average content of? I also don't know. That's why I'm asking. Average content of organic, nitrogen level in organic fertilizer. What is the nitrogen level in urea?
46%.
46%. Similarly, what do you think about the nitrogen content in organic fertilizer? Anyone? Percentage wise?
12%.
Huh?
12%.
12%. Okay, some organic fertilizer with 12%. Anyone? Right. So it may vary, depend on the raw material that you are taking for organic matter. It varies. Let's say minimum is 3%, maximum is 12%. Normally, this is the nitrogen percentage in an organic fertilizer. Right. Now, I'm going to take this factor A as organic nitrogen content in the organic fertilizer. So that is my factor A. That is my factor A. So I'm taking a range of values. As an example, starting from 3%, 4%, 5%, 6%, 7%, 8%. Right? Even though it is very high, 9%, 10%, 11%, and 12%. These are my levels. I cover almost all range of possible nitrogen content of the organic fertilizer. Right? Similarly, I'm going to combine another factor, factor B, because just I want to study the combination of integrated nutrient management. When you say integrated nutrient management, we manage the nutrients using organic and inorganic. I'm going to use, let's say, nitrogen in inorganic. Nitrogen fertilizer inorganic. So what are the possible nitrogen fertilizer used as inorganic in the agriculture field? Urea. So that we know 46%. Ammonium sulfate. What is the percentage? What is the percentage? Soil group, soil specialization, agronomy specialization.
21%.
20? 20?
21%.
21%. Okay. What are the other nitrogen inorganic fertilizers available?
21.
What are the other inorganic nitrogen fertilizer available? Mahajini, you can, if you have problem with mic, you can send it through chat. Yeah.
Ammonium chloride.
Ammonium chloride. Are we using? I don't know. I'm just asking.
Ammonium nitrate.
Huh? Ammonium
nitrate.
Ammonium nitrate. Okay. Ammonium nitrate. What is the percentage? I don't know. What is the percentage?
33.
33. Okay. What are the other fertilizers that they are using? Any fertilizer? Because I don't know. That is why I'm asking. Tell me one or two more. The inorganic fertilizer. Problem, you type it. You are singing song, type it on the chat. I can pick it up.
Potassium nitrate.
What I'm talking about nitrogen source. Huh?
Ammonium sulfate.
Ammonium sulfate. Okay. Ammonium phosphate. Ammonium phosphate, is it ammonium sulfate, ammonium phosphate? Are they a supply of nitrogen? I'm just asking. Right, as you said, ammonium sulfate. What is the percentage?
Ammonium sulfate already wrote.
Ammonium sulfate already wrote. Okay. So give me one more example. Let's say something. I will say B4 and B5. Just for our example. So now I want to, because remember this A and B is because we are talking about only nitrogen source, not the other things. All right. So when you talk about this nitrogen source, we have factor A, factor B. Factor A is organic, factor B is inorganic. That is what we said. Now, how many levels are there in factor A? Count how many levels? Anyone?
10 levels.
10 levels. 10 levels are there. In factor B, five levels. Right. Now, if you combine these two, what is the total number of treatment combination? What is the total number of treatment combination? So we have 50 treatment combination. For example, 3% of organic matter plus urea. 4% of organic matter plus urea. 5% of organic matter plus urea. So likewise, you end up with the 50 different combination, right? 50 different combination. This is the last combination. 12% urea, 12% organic matter plus inorganic fertilizer of B5. So we have this. We have 50 treatment combination, right? Now, do you think is it easy to incorporate all 50 treatment combination in the experiment? Very difficult. So that maybe we take randomly out of this 10 combination of factor A, we take maybe 4. We take 4. Out of 5, we may take 3. 3 randomly select, right? If we select randomly, for example, 4 randomly, 4 levels randomly, we don't know what are the levels that we are going to select from factor A. Similarly, from factor B, we select only 3 levels. We don't know what are those 3 levels. We already talk about different levels. So if you take this randomly, so factor A effect is random effect or fixed effect, because we have taken the levels randomly. Out of 10 levels, we have taken 4 levels randomly. So that factor A is called as random effect. Similarly, factor B is also called as a random effect. So what is the advantage of this random effect is we can generalize. We can generalize the results. We can generalize the results. That is the importance of this randomization. Right? So from the a lot of combination, we are taking that. Right. Now, let's say, I will take another example. Factor A. In cutting, what is the chemical that induce the rooting of cutting?
Ruton.
Ruton. Normally, what is the percentage we are using Ruton? ppm? Anyone? Let's say, I don't know, this is 10 ppm Ruton. This is 12 ppm Ruton. This is 14 ppm Ruton. This is 16 ppm Ruton. These are the levels that I am taking ppm from Ruton. Now, I'm taking, let's say, I'm going to test the rooting ability of T. Rooting ability of T. So here, I'm taking clone. Let's say clone 1, clone 2, clone 3. Have you learned about this clone? I need the answer. How do we propagate T? Is it vegetative or is it seedling propagated?
Both possible, but mostly vegetative.
Yeah, both possible. Nowadays, we don't propagate through seedling, right? Nowadays, in a commercial level, we never propagate now through seedling. Now only vegetative, because we don't want to change the characters. So vegetative propagation. So we are propagating through clone. So we have clone 1, clone 2, clone 3. We want to test the rooting ability of this T using this Ruton. Ruton, we have different concentration because we don't know which concentration is good for which variety or which clone and so on. So here we have 4 levels of Ruton. Here we have 3 levels of variety. So I have combining this 4 into 3. So this is the levels in Ruton, right? This is levels in clone. We are talking about only T. So we have 12 treatment combination. I have 12 treatment combination. If I apply this all 12 treatment combination in an experiment, in this situation, the effect of A and the effect of B, for example, both are called as fixed effect. Both are called as fixed effect because out of 4 levels of this Ruton, we are taking all 4 levels. No any randomness maintained there. Out of 3 levels of clone, we are taking all 3 levels of clone for the experiment. So no randomness we are applying there. Therefore, these effects are called as fixed effect. So these fixed effect, we cannot generalize. We cannot generalize. What do you mean by cannot generalize? For example, let's say here in this experiment, as a factor B, I have considered only 3 levels of T clone. So the results, whatever the results, right, can be applied only to these 3 clones, C1, C2, and C3. I can apply to only these 3 clones. I cannot apply to the other clones. That is called as we cannot generalize, right? So this effects, because I'm not going to talk about much of this. So these effects are called as fixed effect. So in our course, we are much more talking about fixed effect. So when you come to the high level, we can talk about fixed effect and random effect. So here, in both A and B, both are fixed. In the earlier case, nutrient case, both are random. So both are fixed, both are random. Sometimes one factor can be fixed, the other factor can be random. Right? For example, I'm taking an experiment. Let's say I have a company, a car company which is renting the cars. Let's say Pick Me. Have you heard about Pick Me? Pick Me are different in Sri Lanka. That is the common network that Pick Me. So likewise, one car company. So they have hundreds of vehicles for renting. All right, hundreds of vehicles for renting. Now, I want to do a small study using this company. Factor A is tire. I'm going to do a small study using factor A, tire. Factor B, driver. So in this company, there may be 50 drivers. Right? In this company, I mean, this particular vehicle can be used maybe different tires. Everybody knows the name of the tire. Give me the ladies, girls, name of the tire. One tire used by vehicle. Kirija, tell me the name of one tire.
Seat.
Seat, all right, okay. Anyone? Give a name.
Maxis.
Huh?
Maxis.
Maxis, okay. Any, huh?
MRF.
Yeah, MRF. Ola, Indians, huh? Right. Girls, there are so many tires. Michelin, Bridgestone, all right. Even DSI, they have tires. Yes, you have plenty of products of tires. So we cannot test all the tires fixing to the vehicle. So for example, we are testing randomly, maybe there are 10 type of tires are there. We cannot combine all these drivers with 10 tires or 10 types of tires, then we'll have roughly about 500 treatment combination. We cannot do the experiment. So we select only 5 drivers randomly. We select the tires, maybe 3 or 4, for example. Then we do the experiment. So you see, out of 10, we have selected 4 tires random. right? Out of 50 drivers, we have selected 5 drivers on a random basis. So that the driver factor is becoming as a random because we have taken 5 drivers on a random basis. Similarly, the factor A, which is the tire, is also become as random since we have taken 4 tires randomly from the 10 tires. So you see, this is what we call as random effect and the fixed effect, right? The analysis for these effects are slightly different, random effects and the fixed effect. However, in this particular course, we are talking about fixed effect, right? In this particular course, we are talking about fixed effect. Even in your final year research, when you come to dissertation, you will mainly talk about fixed effect. We never go for random effects. It's very difficult. We'll have to choose from a pool of random. Right. Any question on that? Little unclear. Yeah. Right. So this is the next design that I'm going to talk about. It's called as nested factor design. Nested factor design. So, for example, when you do a nested factor design, right? Let's say I'm going to district 1, district 2, district 3. So first level is district. First level is district, right? So this is, we could say the first level as factor A. Factor A is the district. Right, another district. We take, for example, villages. I will take villages. This is my factor B, villages, because different villages, right? Village 1, village 2, village 3, village 4, village 5, village 6, village 7, village 8, village 9. Now, under each village, I'm taking the information from the farmers. So this is my third level, factor C. Right? This is my third level, factor C. Let's say for each village, I have several numbers. Here I could say farmer 1, farmer 2, farmer 3. Similarly, farmer 4, farmer 5, farmer 6, and so on. You can draw it. Farmer 7, 8, 9, and similarly 10, 11, 12. So that is the farmer level. So what we try to say here is, the most importantly, you see village 1. This village 1 under which district?
District 1.
District 1. Can we say village 1 can go to district 2?
No.
No, because why? Because this village is unique to that district. Let's say I'm taking, this is, let's say you all are familiar with Kilnochi. This is Kilnochi, this is Jaffna. This is, let's say, Mana, 3 districts. Since you are from, studying from that day. Kilnochi. We say this is village 1 is Uritrapura. Village 1 is Uritrapura. Village 2 is, I don't know much of the name. Let's say Ramanathapuram. Ramanathapuram, right? Ramanathapuram. Ramanathapuram. Oh, whatever it is. Oh, I'm writing in Tamil. Ramanathapuram. Okay. Uritrapuram, Ramanathapuram. Then village 3 is your famous village, Arvial Nagar. 3 villages. Similarly, in Jaffna, I'm taking 3 villages from, this is from, let's say, Alavatti, a village in Alavatti, a village in Chunnagam, a village in, let's say, Nalekatwan or somewhere. So likewise, 3 villages in Mana. Let's say this is Silavature. This is anybody from Mana? You can say Budataltiv, right? This is, let's say, Mana. What do you call this? The peak of the Mana, where it is. Talamannar, let's say. Talamannar. So you see, I have just given the name of these villages. Here, the villages has a speciality. Correct? What do you think about this village? These villages, we can say villages are nested. Within districts. We can say villages are nested within districts. Correct? Okay. Is it clear? Villages are nested within the district. So that means village 1, 2, 3 is nested within district 1. Village 4, 5, 6 is nested within district 2. Village 7, 8, 9 are nested in district 3. Similarly, if you look at the farmers, these 3 farmers nested within village 1. So farmers are nested within what? Villages. Farmers are nested within villages. So the first 3 farmers belongs to village 1. The second 3 farmers belongs to village 2. Right? So village 1 cannot make a note of it. Village, I will put it as the V1 cannot cross over with district 2. So this is more important. So that means village 1 is nested within district 1. So this terminology is called as nested. Nested means in Tamil it is அதுக்குள்ள கூட அமைக்கப்பட்டுள்ளது. Right? In Sinhala, how do we call in Sinhala? Anyone? Nested. In Tamil, அதுக்குள்ள வரையறுக்கப்பட்டுள்ளது. In Sinhala, a district ඇතුලේ ඒක ඇතුල් වෙනවා. ඒ village එක district ඇතුලේ ඇතුල් වෙනවා. වෙන district ඇතුලේ village එක යන්න බැරි. Right? So that is called as nesting. Okay? So this is the principle of this kind of design. So when you do a lot of work, especially coming up with doing questioning, some of your colleagues who are in the different departments, maybe food science or maybe economics department, they do a lot of research on this questionnaire survey. So you could see how this has to be analyzed. You cannot simply analyze as we want. So it could be treated as a nested design. Right? So here, when you talk about these three effects, we said the district, right? What are the three factors here? We have districts, village, and farmers. Here, tell me who, this is factor A, this is factor B, this is factor A, this is factor B, this is factor C. Now tell me, based on your knowledge, which is random, which is fixed? Anyone? Which is random, which is fixed?
Districts may be random, village and
Okay.
farmers are fixed.
Very good. District could be random. We can select any district as we want. Right? Because district is more random. But villages are fixed within the district. Or villages are nested within the district. So that here villages are fixed. And the farmers also fixed. You see, when you talk about analyzing these factors, we are not going to treat these three factors in a similar manner. We treat these two factors in the same way, and this factor slightly different when we do the analysis. We are not going to talk about that here. Right? But when I put the ANOVA table, you will realize what it is. Right? Right. Now, some more examples on nesting. I gave you some example with agriculture, farmers with villages, another district. Not necessary agriculture, we can take some other examples also, write down these examples. You see designs where the levels of one factor are nested with other factors. So that means these factors cannot cross over. These factors cannot cross over. Examples, right? Classroom nested within the school, isn't it? Because you see, school 1, school 2, school 3, for example, school is first factor, classroom is the second factor. So I have classroom 1, classroom 2, classroom 3. Then in the school 2, I have classroom 1, classroom 2, classroom 3. So you see classrooms in school 1 cannot be crossover with classroom in school 2. Right? Anybody from Royal College, Ananda College? Right? Some of the classrooms in Royal College is not same as the university classrooms. They are well ahead, very nice classrooms. Right? Not all, but some of the classrooms. So you see, we cannot compare the classrooms of one school with the classrooms of another school. Let's say we have a rural school in Kilnochi, Urutrapuram or somewhere. Can we compare the classrooms in Urutrapuram school with the classrooms in, let's say, Hindu College, Jaffna Hindu College? Or Central College, Jaffna Central College? Can we? No, we cannot. Why? Because it's depend on the facilities of each school. So it is location specific, right? So this phenomena is called as nesting. So we come across nesting a lot in the experiments, right? So this is one example. Classrooms nested within the school. Village nested within the divisional secretariat divisions. So we cannot compare all the villages across all the divisional secretariat. Some villages are very well established, some villages are very low established, and so on. So it is nested within the divisional secretariat, right? Similarly, farmers nested within the villages, right? Right? We can take several other examples. Another example, hospital waste. What do you think about the hospital waste? It's depend on the size of the hospital. What are the activities that they are taking in the hospital? The base hospital, they do a lot of operations. So the waste is different. Some village level hospitals, they don't do much operations. They do some cleaning of wound and that's all. If their wound is very big, they send it to the base hospital or the teaching hospital, depend on facility. So the hospitals waste, because it is a very big waste. So district. Another district also, you have different types of hospital. Let's say Jaffna district, teaching hospital Jaffna. It's a very big hospital. So the waste is very high. That you cannot compare with the hospital in Chunnagam or Punnalagatwan or anywhere, right? That is the biggest hospital within the district. Maybe the second biggest, maybe the hospital in Point Petru, for example, right? So likewise, these hospitals are nested within the district. Hospital, the activities or the characters are different. So the third one, the daily waste. For example, if you figure it out, this is district. Let's say district 1, district 2, district 3. Then we have the hospital, different hospital. Let's say H1, H2, H3, different hospital. H4, this is 4, H5, H6, and so on. Different hospital. Even within different hospital, the daily wastage, wastage 1, wastage 2, this is different. We cannot cross over this with the other hospital, even within the district. So here we have wastage, here we have wastage, right? Then we have a few replicates. We can take some replicates, right? Under the daily wastage, we can take 3 replicates. Under the each hospital, for example, So that is possible, right? So likewise, this is an example if you come across with the hospitals. All right. Now, another example, compare paddy yield in districts. District, villages or farm, then the different farmers. Under the village, different farmers. Farmer 1, farmer 2, farmer 3, and so on. Another example, animal science, for example, tick study. You know what is ticks, right? It is parasitic, right? Tick studies, we can say ticks are nested within the district or within the divisional secretariat, or because ticks are, we don't collect the ticks directly, we collect it from the animals. So we collect it from the cows or maybe any other animals, right? Dairy cows or whatever it is. So all these are coming as nested. So the thing is, factor B will not cross over with factor A. That is the most important phenomenon. There's no any crossover happening, right? We say that B is nested in A or within A when the levels of B are unique. It is intrinsic to a given level of A. Nested design can also talk about the incomplete factorial design. I'm going to show about what is the difference between factorial design or factorial setup. So what is the difference between nested design and factorial setup? I'm going to show you an example, right? Nested and the factorial. What is the difference between nested and the factorial, right? So basically, from the text, you can understand in the nested design, it is like an incomplete factorial design combinations. For example, in factorial A, we have two levels, A naught, A1, factor B, B naught, B1. So what are the combination here? A naught, B naught, A naught, B1, A1, B naught, A1, B1. So we have 4 treatment combinations. In a nested design, we cannot find out all these 4 combinations. That is the difference. I will show you in a few minutes how it is. So we cannot find out all possible treatment combinations. You see, some treatment combinations are not possible. We will see that in the next table. Right, now look at a simple example. This is nothing to do with our direct example on agriculture, but consider a company that purchases its raw material from 3 different suppliers. Raw material from 3 different suppliers. So definitely there will be differences in the raw material. Supplier 1, supplier 2, supplier 3. 3 suppliers, right? Raw material. You know what is raw material? From 3 different suppliers. The company wishes to determine the purity of the raw material, whether this purity of the raw material is same from each supplier. So that is their main objective. So we have 3 suppliers. Now we have, because even in the suppliers, the raw material we are giving this week. Supplier 1 giving a raw material this week, in 2 weeks' time, in 4 weeks' time. Even there will be a difference between the same supplier, right? Because it is called as batch. The production is based on the batch, different batch, right? There are 4 batches of raw material available from each supplier, and 3 samples are taken from each batch to measure the purity. So this is how it goes. Suppliers, batch. So even one supplier is producing 4 batches. The most important is this one is not same as this one, right? Or this 2 is not same as this 2, because that is from different suppliers. Even though I have put it the same name, so this we can say supply 1, batch 1, B1, B2, B3, B4, for example, you can write down B5, B6, so likewise B9, B10, and so on, you can write. Then it is more clear for you. There's no any crossover. Can you all hear me? Langda?
Yes.
Yes, sir.
Okay. Right. Yes, this is, I have 3 replicative, which I said already. You see, 3 samples have been taken from each batch. So batch 1, I have 3 samples. Batch 2, I have 3 samples. You see how the samples have been coded. You see how the samples have been coded. You see Y11. So Y111. The first indicating the supplier. Second digit indicating the batch, which batch it belongs. The third digit, it indicates the replicate. You see here Y111, Y112, Y113. This is from the same supplier, same batch. This is from same supplier, same batch, but different replicate. You see, this is how it works. Any questions on this? Look at this. I will come in 1 minute, getting some water. Any questions? Any questions on this? So this is the setup of an example of factorial. We call nested design. Let's see a factorial design. We are going to compare the nested and the factorial. Let's look at all levels of one factor crossed by all levels of another factor. This is basically the factorial experiments. That is to say, all possible combinations are represented. If you can fill this table with the unique replicate, it is factorial. For example, I'm taking this is one factor, right? the type of plants is factor A, pea plant, bean plant, corn plant as an example. These are types of plants, right? We are doing an experiment in ambient temperature of ambient CO2, that is mean the normal CO2, and we are giving a CO2 concentration double the CO2 concentration. So the second factor is CO2 concentration. So this is first factor we could say, rather than saying A, we could say it is crop, different crop with different CO2 concentration, the second factor. So this is factor A, this is factor B. Right? Now, if you can fill all these, then it is called as factorial experiment. So in this case, for example, this is pea plant with normal CO2 concentration or the ambient CO2 concentration and double CO2 concentration. Then we can replicate this. This is all the possible combination we can replicate. Bean plant with normal CO2 or ambient CO2 and double CO2. Corn plant with ambient CO2 and the double CO2. So all these are possible. All combinations are there. If you look at the nested design, you see here, I have a small experiment. Maybe it might have no fertilizer, nitrogen fertilizer, and phosphorus fertilizer as an example. So here we have used strain A, strain B, strain C, D, E, and F. And these are replicates for each of those strains. So these strains A and B are nested within zero fertilizer. Strain C and D are nested within nitrogen fertilizer. So likewise, we can explain that. So here in this example, strain type is nested within fertilizer. Right? Fertilizer is not often called group. Strain is often called as group. Right? Fertilizer is because it is the first level, first factor, right? This is factor A. This is factor B, subgroup, right? So this is the group. This is subgroup. Here, nested factor is always random. So nested factor is always random. So we could see that, right? So this is the setup for this arrangement. For this arrangement, actually, this is the setup. So where we have fertilizer, no fertilizer, nitrogen fertilizer, phosphorus fertilizer. Strain A goes only with no fertilizer. For here, no combination. For strain C and D only goes with nitrogen fertilizer. Without fertilizer, no combination. With phosphorus, no combination. For strain E and F, only phosphorus fertilizer is there. So no other combination. So you see, so this is the problem in nested design. Nested design, this is the problem. All the combinations are not there. So therefore, we'll have to be a little careful when we do the analysis, right? I will just put up this setup again, just for you all to recall it. Right, you can make a note of it. Variance within the group, that means no fertilizer, nitrogen fertilizer, and the phosphorus fertilizer. If you calculate the variance, Among no fertilizer, nitrogen fertilizer, phosphorus fertilizer, that is called as group variance. If you calculate the variance between strains, subgroups, strain between A and B, you calculate the variance plus the variance between C and D plus and so on. Then it is giving us subgroup within a group. You understand, within a group. The third one, third level, variance among all the subgroups. Variance among all the subgroups. So that is actually, later we will talk about different components. So one of these components will function as the error. You see here, you make a note of it. I will discuss this in a few minutes. You see, in this above example, there are 3 levels of A, 2 levels of B, and R is a replicate, which is 2. So this is how the ANOVA looks like, right? This is how the ANOVA looks like. Now we are going to write down the ANOVA, make a note of it, then we will go for the ANOVA. Model and the ANOVA. Right. We'll go with the first situation, and I will, let's say, factor A is at district 1. Factor A district. The early example, I recall it. District A, district B, district, sorry, I'll put it as D1 and D2. D1, D2, and D3. So this is my 3 districts. Then the second factor, B, is village. Let's say I have 3 villages as an example. Village 1, village 2, village 3. Village 1, village 4, village 5, village 6, village 7, 8, village 9. Right? The factor 3 or factor C is farmers. So let's say this is farmer 1, farmer 2, farmer 3. So you can write down the rest. Farmer 4, 5, 6, and so on. So under each farmer, we could collect a replicate, 1 or 2 replicate. Let's say this is for Maha replicate. I will say collect the information for replicate, first replicate, second replicate from the same farmer. So likewise, you can collect first replicate, second replicate from second farmer and so on. Now I'm going to write down the model based on this, which I have already given, right? So you can write the model for 3-stage testing. So earlier example is actually 3-stage nesting. So that I can write Yijk is equal mu plus alpha I plus beta j within I. This is how we write it, plus this is how we write. You write down, I will explain. Right, what is Yijk? Anyone? We could define this I is from 1 to we will general term A. J is from 1 to B. K is 1 to R. So A mean factor A, B mean factor B, R mean replicate. So small a mean it is the number of levels of factor A. Small b mean number of levels in factor B. Right. Now we can define the terms. What is Yijk? Anyone? How we can define Yijk?
Observed value in J factor.
Start from I. Observe value of I factor A. Observe value of I factor A.
J factor B.
Yes, jth factor B. In jth factor B.
And
In
in K factor.
kth replicate. K is not a factor. K is replicate. So write down. Observe value of ith level of factor A. Same as early. Same as normal factorial experiment. So here we don't talk it nested in this y component. So it is just the value of ith level of factor A, jth level of factor B, kth level of replicate. That's all. Finish. Then mu is, as you all know, it is a grand mean. Alpha I, it is same. Anyone? How we can express alpha I? It is the ith factor A effect. Ith level of factor A effect. Ith level of factor A effect. So here, for example, let's say we are taking this district, village, farm. Tell me how we can write alpha I. District, village, farm. 3 levels. 3 nesting. How we can consider it is the ith district effect. Because factor A is a district. So we can say ith district effect as an example. So look at this second one, beta ji. Now we'll have to carefully handle this. What is the J in this example? It is village, for example. It is village. It is village. Now tell me, it is the jth village effect. What is within the bracket?
Of district I.
Yes.
Of district I.
Yeah, we'll have to tell slightly in a different terms.
Nested village.
Jth village effect. Why this component is coming bracket? Within. So this bracket is actually within, indicating within. Jth village effect within.
Nice.
Within.
District.
Within what? Within the bracket, what is there?
Within
Ith.
District.
Ith district. Within Ith district. Within Ith district. Right? Now you should be able to explain this. Can somebody say? It is there. This is same as actually this. This is same as this. But we have put bracket. Yes, go ahead.
Kth replicate effect of kth replicate within J within J and I.
Yeah, we'll have to tell what is this J and I.
Within J village, within Ith district.
Yes. So this is the random effect. Effect of kth replicate. It is the random effect of kth replicate within jth village and within, you can write within jth village and ith district. Within jth village and within ith district. Okay. Sorry. Any questions? So this is the model, right? This is the model. Actually, we said earlier, in this example, we have factor A, factor B, factor C. So this is district, right? Factor A could be district, in this example, district, here the village, here farmers. Even though we said earlier, the fixed effects and the random effects, if you talk about each level separately, the district level, we can have fixed effect or random effect possible in the experiment, right? Earlier we said the random effect, but we can have a fixed effect also. Let's say I'm going to do a study only 3 districts, Kilnochi, Manna and Jaffna. I'm not going to take other districts. So it is a fixed effect, right? Random effect means, let's say I'm going to take all the districts in Sri Lanka, then I choose 3 districts from all the districts in Sri Lanka. Then it is a random effect, so that we can go either as a fixed effect or random effect. It depends on what we are doing. Here, again, the same problem. normally here we go for random effect. Because why we go for random effect? Let's say district 1. In district 1, there may be 30 villages. We cannot take all 30 villages in this district 1. So we may take 5 villages. How do we choose this 5 villages? On a random basis. How do we choose this 5 districts? On a random basis. But sometimes if you come to research, some people are taking that as a fixed village because it is easy for us to take the data. So normally, this is the situation because under the district, you have several villages. I choose maybe 3 or 4 or 5 villages, right? Sometimes people do research in a particular village, right? Why? The reason is it is closer to my house so that I can collect the data. Do you think is it a good answer for a good researcher? இந்த வீட்டுக்கிட்ட அந்த இடம் இருக்குது ஆகவே நான் அதில் ரிசர்ச் செய்கிறேன். Do you think is it a good idea? මගේ ගේ ළඟ තමයි රිසර්ච් ප්ලොට් එක තියෙන්නේ ඒ නිසා මම ඩේටා ටික ගන්න. හිතනවාද ඒක හොඳ උත්තරයක් කියලා? Researchers? No, it is not. Because you are biased. Can you remember? We talked about biased. We talked about biased earlier also. So we shouldn't be biased. We shouldn't be biased. Right? So that is the thing. Similarly, the story is true with the farmers also. We cannot select the farmers. Under the village, let's say under the village, we have 3 or 5 farmers. 1, 2, 3. Right? F3, F4, F5, and so. How to select these farmers? Do I select the farmers who are closer to the main road? How do you select my farmers who are closer to the main road, who are with tractor? Do you think that is a good idea? No. You have to select the farmers also on a random basis. So usually, even though I say these are random, usually what we do is as a research, without knowing to our knowledge, we are doing fixed effects. Later, I will show you fixed effect. What is the difference between fixed effect and the random effect? Huge difference in the analysis. So this is the story. Now I am going to put up an OR table for the above example model, above model, right? So I will fix an OR table. I'll put it as in shortened form, source of variance. You also write clearly source of variance, degrees of freedom, sums of square, mean square, and the F calculated value. Tanesh Kumar?
Yes, sir.
Like evening என்ன மாதிரி class?
ஓம் சார் போடலாம்.
நான் போடலாம் இல்ல கிளாஸ் போட்டாச்சு அதான் கேட்கிறேன்.
ஆமாம் சார்.
என்ன பிரச்சனை என்றால் மற்றவர்களுக்கு SAS are there, everybody is having SAS or still people are having problem with the SAS?
Yes sir, I told to sir and convey the message. I think except one person, all the persons are okay.
Right. So anyone having problem, just to get to know? කාටරි ප්‍රශ්නයක් තියෙනවද ආරක මේ දවස් ප්‍රශ්නයක සැසල because you'll have to run the program and you'll have to do the screen share today afternoon in the because it is a practical no. I don't know what you are doing. So everyone I will name, so you'll have to do the screen share after submitting the program and so on. We'll do examples, right? So anyone having problem with the SAS? Yes or no? Tadu sir? Yeah, I have a chat, yes. Who is 1076? Who is 1076? If you don't tell me, I will catch you who it is. Who is 1076? Yes, the Yadurshi. Yadurshi. Are you Tamil or Sinhala? Near Valana Varathaku Gampirathina. Classic earlier Rekanda, earlier one announce Pandita. It's a department. Then time around class. Cherry, Trivi Kada Silicon Kela. Urukade or Katanjala. Paladar Cholila. Right. Who is having a problem with the laptop? One person has sent a message that having problem, but others more or less okay, I think. I don't have a laptop or desktop, sir. Right. We will see. We will see in the afternoon how who is not having laptop or desktop. Can you share with your colleagues or maybe I don't know how I can. Yes, I cannot. I am not the computer man to repair your laptops. That is not my problem. Yeah, let's see. We'll have to do the practical no anyhow. So I'll have to do it in the afternoon. Anyhow, you all have to come. At least you can write the commands and so on. You can try a little later. Anyhow, you will get questions from my part also from the SAS. Right. We will go back to fill this table, ANOVA table. So I will put it as first source of variance. Let's say A.
Sir,
Yeah.
that model, sir, we consider only two factors, district and village, but the farmer effect also there, sir, in this question. Then
Yeah.
before replicate, we want to put farmer effect also, isn't it?
Yeah. So here, yes. You mean in the model? What do you mean by the here? Here is you asking in this question? Oh,
Yes, sir.
yeah. So here basically, here we are comparing. I mean districts. So district is level A. Factor B, which is village, it is second level or second step. Then the farmers, right? So thing is, because it is the third level, actually, even if you remove replicate, actually, if you remove replicate, because I have just normally if you remove replicate, this would be work. If you don't remove replicate, then you can include, as you said, farmer effect also. usually we don't consider the farmer effects, right? We don't consider the farmer effects because farmer to farmer effects we don't consider in an experiment, right? So if you want to consider, here we are testing factor A, here we are testing factor B. Actually, there's no testing for factor C. Actually, this factor C is coming here, right? In this case, factor C is coming here as a total component for the error, right? Factor C is coming here. Suppose if I want to really test the farmer's effect, right? Here I will erase, give me a second. Now say farmer's effect. I will take only one at the moment. Let's take village 1, farmer 1, farmer 2, farmer 3, right? So here, this farmer 1 and farmer 2, we can consider it as a factor C, farmer. That is possible, right? We can consider it as factor farmer C. Then if you consider factor C as farmer, then we'll have to have replicate from one single farmer. Right, like this.
Then sir, this model without replicate.
Yes, and this model we could include one more items here. Actually, this will divide it into two components, right? So that is factor C. Then actually this is we can then we will have to include one more levels. One more level has to be included. IJKL, right? Because L we are missing here, because here we didn't talk about the third factor. So L is HI, I will remove it other way. Then we can see this is A, B, C. This is C. This is 1, 2, R. You can do it in this way. Right? So actually this is the 2 factor. This is, even though I said it is 3 factor, you can change it as a 2 factor, right? 3 factor at the end, after giving this ANOVA table, I will give it for the 3 factor, right? So you can change it for 2 factor here, so that will solve the problem, right? So if it is for 3 factor, I will explain at the later stage. Right, factor A, we have the levels of factor A is small a, so that A minus 1. The second source is called as B within the A. This is how we write down the ANOVA table. So B is nested within the A, so we can write it as A into B minus 1. What about the third one? We have total and we have residual. Make a note of it. In the residual, we can write it as C within A within B. So this is actually the third factor we considered as a replicate. That is the situation, right? Third factor we considered as a replicate. So we can write it as such, right? So here the total is A, B, R minus 1. So that residual could be written as AB into R minus 1. Okay. Clear? AB into R minus 1. In this case, The residual is same as the C within A, B. Right. The notations, summation, sums of square, total sums of square is easy, y, j, k, in this case, square, minus the correction factor, as usual. So the correction factor, I will write it here. That is y dot square divided by ABR. All right. Then we will come to the sums of square of A, that is summation y I dot square divided by BC. BR, but BR minus our correction factor okay. The second one, summation, look at very carefully, summation y I j dot square divided by r minus summation y I dot square divided by br. So here we don't use the correction factor. So actually, you see, this is same as this. So that component is coming as a correction factor for the second component. The third one, summation y I j k whole thing square minus, right, that is the total sums of square, right, minus the summation, it comes here, that is summation y ij dot square divided by r. This is the difference in the ANOVA table. You see, this ANOVA table is slightly different from the conventional ANOVA table that we have already learned. So the correction factors are different. So mean square, we can say sums of square of A divided by A minus 1, sums of square of B within A divided by A into B minus 1, sums of square of error, I put it as sums of square of error divided by AB into R minus 1. So actually here R mean it is the farmers, huh? If you don't have any replicate. Right, we have another 20 minutes. I will just give a guideline. Let's say you have factor A, let's say A1, A2, A3, whatever it is. Factor B, B1, B2, B3, likewise it goes B4 and it goes, right? So this is factor B. Then here we can say factor C. So likewise it goes. Any number is possible, right? So this is C level. Now we have C3 levels with replicate. Here, this is rep. R1, R2, R3. Similarly, different replicate R1, R2, R3. So this R1 is not same as this R1, different replicate. So now this is actually a three-factor situation. Earlier also 3-factor situation, but the third factor is not replicated. Third factor is not replicated. Now the third factor is replicated. Now we have different effects. So we can say factor A is from, let's say, 1 to A. Factor B, or I can say in notation, I is from 1 to A, J is from 1 to B, K is from 1 to C, and L is from 1 to R. We will identify the R separately or the replicate separately. Here we have 3 levels. Earlier also we had 3 levels, but without replicate. Now, earlier the third level has been considered as a replicate. Now we are having a separate replicate. Now we have a different story. Y, I, J, K, L. So everybody should be able to explain what is this. It's equal grand mean plus alpha I plus this is I is the effect of A, factor A, beta J within I plus gamma, for example, Ij K within J within I. Right. Now we have the random effect of L within K within J within I. We can write it like that. So here, this is indicating the effect of factor A. This is indicating the effect of factor B. This is indicating the factor C, because C has a replicate. Sri Divagaran, did you got it?
Yes, sir. Thank you.
Okay. So earlier it was, replicate, without replicate. So that may be the confusion that you had it. Right. Now we have a replicate. So we have all these 3 factors. How we can write down the model? ANOVA. Anyone? Source of variance, degrees of freedom, sums of square. I will focus only these 3. What are the source of variance? A. What is the degrees of freedom? A minus 1. How to write the sums of square? Summation y I dot square divided by not A, B, C, R minus the correction factor. So everybody knows what is the correction factor. Correction factor is y dot square divided by A, B, C, R. Okay. Is it clear? So this is the first component. Second component, factor B nested within A, so that we could say it as A into B minus 1. So that is summation y I j dot square divided by CR minus this component coming there. That is summation yi dot square divided by BCR. Right. Then we have the third component, C within B within A. So that is, we could say it is the A, B, C minus A, B, C minus 1. That is summation y I j k dot square divided by r minus summation y I j dot square divided by cr. And we have residual. Actually, residual is a, we can say R is within C, within B, within A. We can write it like that also. And the total. So these are the all component. So the total is, as you all know, A, B, C, R minus 1. We could say this is A, B, C into R minus 1. Right? So here we can give the total sums of square y summation y I j k l whole thing square minus the correction factor. Right? So here the residual can be calculated as summation y I j k l whole thing square minus summation y I j k dot square divided by r. Or otherwise you can say total minus the rest. That is also possible. But here you can give it. Right. So I will. Any questions? Right. What is the difference is, I just brief it. When testing comes, we have a bit of problem. I will take the earlier one. I erase this space and I used here. First, I will show you the testing here. The first time one, right? Here, the testing. So if I want to test, right? Main effect A. If I want to test main effect A, the calculation goes as this. The calculated value is the mean square of A, divided by mean square of B within A. So you see here, we are not using the error component to divide this. My null hypothesis is alpha I is equal to 0 and alpha I not equal to 0 in this case, right? So we are testing the main effect. You see the sums of square, we know the mean squares that we can calculate. So this is the mean square of A. This is mean square of B within A. So this is the mean square of error. So I will say mean square of error. You see, this is how we test it. Is the main effect of A. Similarly, if I go for testing main effect of B, factor B, if I want to test factor B, then my calculated value is based on mean square of B within A divided by mean square of error. So here we are testing the what do you call null hypothesis is beta k within I is equal 0. This is what we are testing. Right, this is the null hypothesis. Alternative is not equal 0. At least one of the effect is different from the others within the districts or within the factor A. So we can express that in other term. We are running short of time. You can work out with this, and next week we can. This is the question that I'm going to give. You can try it as a homework. I'll skip all this. Right, so this is the example. This is the example. Take it down. Place the ANOVA and test for. Here we have two main factors. What are the two main factors? First factor is area. How many areas are there? Take down this question. 3 areas are there. Under each area, there are sides. 4 sides are there, equal. Not necessary to have equal, right? In this example, we have equal. Replicate is there. So that is the replicate. So you will have to take down all these information. Now you can construct the ANOVA table. M into S into R, that means number of first factor M is 3, number of second factor S, which is 4, and the replicate 3. If you multiply all, 36 data points are there. So find out the effects of area and the site. We can continue tomorrow with that. Everybody should answer tomorrow, right? So you can work it out. You have the formulas, right? You can work it out. Right, I think I can, if you are finished with this, you can leave. If you have taken down these notes, you can leave. The testing we will see tomorrow.
So excuse.
Yeah. Yes. Hello. I didn't get who spoke to me. I couldn't hear anything. Can you all hear me? Yes.
Yes.
Yeah. So somebody asked any question. Right. If you
So
have
that calculated value, calculated value for 2 main effect A, main effect B, if it is in 3 factors, then the main effect B is divided by mean square of C, isn't it, sir?
main, I didn't get. Yeah. If you have 3 factor, yes, I didn't get the point.
Sir, can you hear me now?
Yeah, I can.
So that calculated value for the earlier 2 equations, if we consider the 3 main effects, then the main effect B calculated value is equal to mean square of
But
B.
you are talking about here or somewhere else? Idilia?
Yes, sir. Yes, sir. That.
Yeah. So here, ask the question. Here we want to test only these two. Here we want to test only whether there's an effect here, effect there. We cannot talk about interaction effect here because interaction effect we cannot talk, because interaction effect to explain it, these levels of B has to cross over with levels of A. Here we don't call it as interaction effect in the nested design. Right. Okay. What is your question, Sivativagara?
Sir, now I got it. We here only we consider two effects. Then only
Yeah. Because we cannot talk about A-B effect. Because to find out A-B effect, all the levels of A should go with all the levels of B. All the
Yes.
levels of B should go with all the levels of A. Here we don't have that facility, isn't it?
Yes, sir.
So we cannot talk about the interaction here. So that is the difference. I showed you the difference between factorial and nested. Here we can talk about only these two factors. Normally, if you are unable to do the factorial only, we go for nested. Nested is not a good design as the factorial. Factorial is the superior compared to nested. Sometimes we cannot get combination. Then we go for nested. Right, we can continue this discussion tomorrow. People who wants to leave can leave, huh? Since you have mock exam, so others can leave, no problem. So we'll not tomorrow, we will meet in the afternoon. So people who are with SAS, get ready, huh? Okay, bye.